A very good morning to one and all. Myself, Dr. Sandeep Bhattacharya. Currently, I am working as a professor and head of the Department of Electronics and Communication Engineering at SR University, Warangal, Telangana state. Today, I am going to discuss about the CMOS technology. CMOS technology is acronym as Complementary Metal Oxide Semiconductor, is a key semiconductor technology used in constructing integrated circuits. It is widely applied in creating microprocessor, microcontroller, memory chips like RAM and ROM, and other digital logic circuits. You can see in the left hand side there is a two different types of transistors are connected in a series configuration. So here this is the structure of CMOS circuit, where one transistor is P-type MOSFET and another transistor is N-type MOSFET. So when we will combine these two transistors in a series formation, then it becomes a CMOS circuit, where the gate terminal for P-type as well as N-type MOSFET is short circuited. Then this terminal is known as input terminal, and when drain terminal for both transistor is short circuited, then the terminal is known as output terminal. So CMOS device consists two transistor and one input and one output. CMOS circuit, just now I explained that CMOS circuit basically consists one P-type MOSFET and one N-type MOSFET. MOSFET is nothing but it is a metal oxide semiconductor field effect transistor. These transistors work together to create logic gates like AND gate, OR gate, then NAND gate, NOR gate, which form the building blocks of digital circuits. So CMOS technology mainly used for high performance and high speed digital circuit design. And the major advantage of CMOS technology is it is low power consumption, especially when transistors are not switching between states. So CMOS is a combination of P-type and N-type MOSFET. So before going to the details discussion of CMOS technology, I want to explain about the P-type MOSFET and N-type MOSFET. So P-type MOSFET, this is the schematic representation of P-type MOSFET, where you can see there is a three terminal. One is called gate terminal, another terminal is known as drain terminal, and another terminal is known as source terminal. Similarly, for N-type MOSFET also, if you see the schematic representation of N-type MOSFET, here also there is a three terminal N-type MOSFET is a three terminal device, where three different where gate terminal, one gate terminal is there, one drain terminal, another one is source terminal. But in the schematic representation, you can see the main difference is in P-type MOSFET there is a bubble, and in case of N-type MOSFET there is no bubble. Circle, one small circle you can see in P-type, it is there, but whereas in N-type MOSFET there is no circle. And come to the physical structure of P-type MOSFET, you can see there is a this terminal is source, this terminal is drain, and this terminal is gate. So source terminal is metal terminal, drain terminal also one metal terminal, metal contacts, and gate terminal also metal contacts. But here source terminal is directly connected with P positive diffusion region, and drain terminal also connected with P positive diffusion region, and in between gate and and sorry, uh, this is, you can see, this is the substrate. This area is known as substrate. So for p-type MOSFET, always we will use n-type substrate material, whereas in n-type MOSFET always we will use p-type substrate material. So in p-type MOSFET, the source terminal is directly connected with p positive region, and drain terminal is connected with P positive region, whereas the substrate material is N-type. And in between gate and substrate material, there is a one thick layer. That layer name is silicon dioxide. So it is looks like a parallel plate capacitor. In the concept of parallel plate capacitor, I think all of you know, there is a metal, one terminal is metal, another terminal is metal. This is one terminal, this is another terminal, and this is metal 1, this is metal 2. So in between metal 1 and metal 2 there is a gap. That gap is basically any dielectric material, either air or silicon dioxide. Any type of dielectric material will be there. So this is the structure of parallel plate capacitor. Now if I consider this structure also, you can see this is gate terminal is metal, this terminal is semiconductor, and middle one is dielectric material. So metal, dielectric, semiconductor, but here in capacitor is metal, dielectric, and metal. So that is the difference. In parallel plate capacitor, one metal terminal is there, in the reverse side another metal terminal is there, and in between two there is a dielectric medium. Whereas in MOSFET also looks like a capacitor, but the difference is one side gate terminal, that is metal, another side substrate material, that is semiconducting material, and in between metal and semiconductor there is a silicon dioxide material or dielectric medium. That's why it is called metal oxide semiconductor. Okay, now in case of n-type MOSFET, see the structure. The structure is reverse like p-type MOSFET. Here source terminal is directly connected with n positive diffused region. This is n positive diffused region, whereas drain terminal also connected with n positive diffused region, and substrate material is p-type, gate terminal is metal, and in between gate and semiconductor there is a dielectric media, that is silicon dioxide dielectric layer. This layer is known as thick silicon dioxide layer, and source and drain both are metal contact. Now when we will combine these two transistor, and this is p-type transistor, just now I told p-type means there is a bubble, and this is n-type MOSFET. So when we will combine this p-type MOSFET and n-type MOSFET in a series configuration, then it becomes a CMOS. Okay, so this is the schematic representation of CMOS structure, and this one is the physical representation, means in our real life circuit how this structure looks like. So you can see the structure of CMOS circuit, where NMOS and PMOS both are connected together. For NMOS structure, you can see this is source terminal, this is drain terminal, and this is gate terminal. So here source terminal is connected with N diffusion region, drain terminal is connected with N diffusion region, and gate terminal is connected with metal. And in between gate and semiconductor, that is p-type substrate, is in between that there is a dielectric material, that is silicon dioxide. And for p MOSFET it is reverse. So the substrate material is n-type, that is n-well, and or substrate material means semiconductor for substrate material is n-type, and the source terminal is connected with p positive diffusion material, drain terminal is connected with p positive diffusion material, and gate terminal is connected with metal. And here also there will be a one formation of capacitor. Now the question is, in this structure, if we connect these two gate terminal, if we connect these two terminal by using metal contact, then this terminal is known as input terminal, and this drain terminal, and if and this drain terminal if we'll connect, then we will get the output terminal. So in CMOS circuit there is a one input terminal and one output terminal. Input terminal is nothing but it is a connection in between two gate terminal, and output terminal is nothing but it is a connection between two common drain terminal where we will get the output value. Now I am going to discuss very interesting part in this technology, because nowadays what are the devices, electronic devices like our daily we are using in our daily life, like laptops, then smartphone, then digital clock, then different of home appliances like micro oven, washing machine, air condition. Everywhere you will see there is a microprocessor or memory. So microprocessor and memory all are based on this CMOS technology. So nowadays without CMOS technology we cannot live. So now I am going to discuss the fundamental principle of CMOS technology, how CMOS device will work. Now you can see in the left hand side, I mentioned I see this is V in, just now I told here P type MOSFET for CMOS circuit. This is P type MOSFET and this is N type MOSFET. So when this is P type MOSFET and this is N type MOSFET. Now here gate terminal is connected together, and from that terminal we will apply input voltage, and at the drain terminal we will get the output voltage. So when input voltage is logic 0, when we will apply input voltage is logic 0, then what will happen? Then P type MOSFET will be acts as a on state device, and N MOSFET will be acts as a off state device. Now the question is, you can ask one question, sir, why when input voltage is 0, then why P type MOSFET will be on and why N type MOSFET will be off state? The concept is very simple. If we look into the working principle of P type MOSFET, the P type MOSFET always activate, or always it will create the channel in between source and drain terminal, that is known as inversion layer. When gate to source voltage gate to source voltage is less than threshold voltage, means when the gate to source voltage or input voltage is large negative voltage. So when large negative voltage we will apply across this gate terminal in between these two terminal, then the minority charge carrier, which is p type of charge carrier, p or holes will attract towards the oxide layer and it will form one inversion layer. And due to the presence of inversion layer, this device will be acts as a on state device. Whereas under this condition, when gate to source voltage is less than threshold voltage, that means it is equivalent to logic 0 voltage. So when we will apply logic 0 voltage at the both of the gate terminal, then what will happen? This N type MOSFET will not create any inversion layer in between drain to source terminal, because this is the negative voltage, and in the reverse side what will happen? Positive or holes will be attracted towards the oxide layer. But to create inversion layer, because n-type MOSFET, if you see the source terminal of n-type MOSFET and the drain terminal of n-type MOSFET is connected with n diffusion region. Okay, but if we'll apply this gate to source voltage which is less than threshold voltage, means large negative voltage, then large negative voltage is available in this side, large negative voltage is available in the gate terminal, but in the reverse terminal what will happen? All minority charge carrier, which is hole, will be attracted towards the oxide layer. As a result, there is a no formation of inversion layer, because here in this region we need negative charge, but here it will form only positive charge. So due to that reason, this device will be acts as a offset device. Okay, so that's why when input voltage is 0, then p type will be p-type MOSFET will create inversion layer or inversion state, or it will form one conduction layer in between source and drain terminal. Whereas in N-type MOSFET, there is no formation of inversion layer with the same condition when gate to source voltage is less than threshold voltage of the MOSFET. So as a result, what will happen? As the p-type MOSFET is acts as a offset device, so there is no direct connection with the main circuit. This N-type MOSFET will be isolated from the main circuit, whereas this p-type MOSFET will be acts as a on-state device and it will form a low resistance conduction path in between power supply to ground. This is ground. Now you can see here I added one extra capacitor, that is called load capacitor, across the output terminal. So the current, that is ID, will flow. ID will flow from power supply to ground through p-type MOSFET and p-type MOSFET, and this ID will charge this load capacitor. So finally, if we measure the output voltage across the load capacitor, we will get the maximum voltage. Means it is like a charge transfer. Okay, so maximum charge transfer will happen from power supply to ground, because as we know the electrical property of the current always try to flow from high potential to low potential region. So that's why current will flow, ID current will flow from high potential to low potential region. So finally what will happen? This load capacitor will be fully charged, and finally uh, across the output across the load capacitor we will get high voltage. So when you can see here, when the input voltage is 0, but we are getting output voltage is 1. So it is looks like a inverter or single input NOT gate. I think you know the property of NOT gate. When we will apply input voltage is 0, then what voltage we will get across the output? across the output, we will get 1. If the input voltage is 1, then we will get across the output is 0. But here, this circuit will perform when input voltage is 0. This circuit will perform this operation, means charging operation. So when output voltage is 1, that state is known as charging state. This condition is known as charging condition, and this CMOS circuit is works under this condition. So when input voltage is 0, output voltage is 1, that state is known as output voltage is 1, means that state is known as charging state. Now the similar operation will happen, but in a reverse way. If we'll apply logic gate at the input terminal of the same CMOS circuit, if we'll apply high logic, means gate to source voltage, when this gate to source voltage, when gate to source voltage is greater than threshold voltage, means when we are going to apply high positive voltage, then what will happen? Now the same condition, when we will apply high positive voltage at this terminal, at the gate terminal for both of the transistor, so that p-type MOSFET will attract, due to the presence of positive voltage at this terminal, at the metal plate of the gate terminal, it will attract the minority charge carrier. For p-type MOSFET, which one is the minority charge carrier? Electron is the minority charge carrier. So minority charge carrier will accumulate in this particular region. That is called electron or minority charge carrier accumulation. So once the minority charge carrier is available here, so we that is actually negative charge carrier. But for p-type MOSFET, if we want to create one inversion layer, what type of charge carrier is required in this region? We need positive charge carrier, then only there will be a formation of inversion layer. So what is the function of inversion layer? Inversion layer is nothing but to create one channel, means it is like one conducting path. It will form one conducting path, and it will create a low resistance or very low resistance path, so that current will flow in that direction. But here it will not happen. Why? Because if we will apply large positive voltage in this region, this particular gate terminal, at the reverse side, negative charge carrier will be attracted towards the oxide layer. So finally what will happen? There will be no formation of positive charge carrier, or there will be no positive charge carrier accumulation in this region. So finally what will happen? This device will be acts as a off-state device, because there is no inversion layer. That means the circuit is totally detached from the main circuit. Off means there is no connection with the main circuit. So now you can see there is if there is this circuit is totally out from the main circuit, that means there is no direct connection with power supply to load capacitor. That means there is no charging path. Now here you can see this is V out. So now this is for p-type MOSFET, and this one is n-type. Now n-type MOSFET, when we will apply gate to source voltage is greater than threshold voltage, means high positive voltage, then what will happen here? Which one is the minority charge carrier? Here what will happen? If we will apply positive charge carrier, then majority charge carrier, that is electron, will attract towards the oxide layer, and it will form one inversion layer or conduction layer in between drain and source terminal. So once this device will be, it will create one inversion layer, electron cloud in between drain and source. Then there will be a low resistance path will be established in this particular region, and finally what will happen here? This load capacitor, you can see I added one load capacitor across the output. Now if input voltage is 1, and at the output, if we measure the output voltage, if there is a no charge, means if the load capacity is not polarized, or if it is unpolarized device, then across the load capacitor, we will get, if we measure this voltage across this load capacitor, then what value we will get? We will get zero voltage. Okay. And if some already some charge is stored here, so that charge will be discharged through this transistor, and finally what value we will get across the load capacitor? That is zero voltage. So anyhow, this transistor, this n-type transistor will create one conduction path from load capacitor to ground through through drain and source terminal. So what will happen? Entire charge will be discharged through this transistor. So across the load capacitor, what value we will get? We will get zero voltage. That is the basic concept of CMOS inverter. And based on this concept, we can implement different types of logic gates. This complementary nature actually reduces the power dissipation significantly, because power is only consumed during the switching from one state to another state, not in a steady state. So you can see here two different types of switching mechanism I explained. One is when input voltage is zero. During when input voltage is zero, this P-type MOSFET is on state and N-type MOSFET is on off state. During that time, the certainly uh, this load capacitor will charge. That load capacitor will charge from low to high. So this transition, during that transition, and similarly in the reverse way, if we will apply logic voltage is 1, then what will happen? Discharging operation will take place. So that is another type of switching. So during that time instant only, it will consume power, and during steady state there is no significant amount of power dissipation. That's why CMOS is nowadays very powerful electronic device for digital circuit design. Now here you can see I simulate one CMOS circuit. I designed the circuit using T-Spice 10R EDA tool, and what I did here, I applied one input voltage. You can see one pulsating DC voltage I applied here. So this pulsating DC voltage is switching from one state to another state, from 0 to 1. So when input voltage is 0 to 1, so what value we will get across the output? You can see output is input voltage is switching from low to high, whereas output voltage is switching from high to low, high state to low state. Okay, so this is the application of CMOS circuit. So we can easily model the CMOS circuit using different of spice simulation tools. So many spice tools are available. LT Spice, then Cadence simulation tool, that is Cadence Spectra, then Virtuoso tools, then T-Spice, then T-Spice schematic editor, then P-Spice student version. Okay, then HS Spice, Synopsys HS Spice, also very popular simulation tool. Using that tool, we can test this circuit, CMOS circuit. So, and here you can see when input voltage is low in this region, then output is certainly switching from low state to high state. Now, what is the advantage of this CMOS technology? The main advantage is it consumes low power. It is a low power consumption device. CMOS circuit draws significant power. CMOS circuits draw significant power only during the switching process, or that is called dynamic power. During ideal state, when the circuit holds a constant state and the power consumption is very minimal. So during that switching time, only during that time instant it will consume power. That power is known as dynamic power. The second advantage is high noise immunity. CMOS has a high resistance to noise, making it ideal for use in environmentals with electrical interference. The CMOS basically it withstand more amount of noise due to its wide gap wide band, and high density. CMOS allows for the integration of a large number of transistors on a single chip, supporting the development of highly complex circuit. The main feature of CMOS circuit is CMOS is scalable, means it can miniature in the size, like not like BJT. BJT process, if we want to reduce the BJT structure, that is somehow difficult and complex process. But in case of CMOS, the size reduction is not a significant. It is not a very difficult process. So that is one of the biggest advantage. So we can easily scale down the structure. So if we reduce the structure of the CMOS, so definitely more number of transistor we can incorporate in a single wafer or single die. Now the question is, where is the application of CMOS? CMOS is actually, now just now I explained, CMOS basically 90 to 95% in our electronic market are based on the digital IC. So 95% digital ICs we are using CMOS devices. Okay, so for example, in processor, I think all of you know, and most of the electronic components without processor, we cannot survive. Means each and every devices needs one processor. So processor is nothing but it process the information based on the user demand or user requirement. Okay, so nowadays all the modern applications like laptop, then pen, then mobile phone, smartphone, then all the advanced electronic devices required one processor, because nowadays all are user based, user interface based. So what customer wants, accordingly that processor will process the instruction, and based on that device will work or application will work. So processor is very important. So most of the processor is based on CMOS technology. So nearly all modern microprocessors are built using CMOS technology due to its efficiency and scalability. Second very important thing is memory chip. Nowadays we are using RAM, then ROM, external ROM, then internal RAM, internal ROM, DRAM, dynamic RAM, static RAM. So many different types of flash memory. Okay, so different of memory circuits we are using, all are based on CMOS technology. Then analog circuit application also, CMOS are very much useful for different of sensing application. Then RF circuit design, radio frequency circuit, radio frequency detection circuit. For radio frequency detection circuit purpose, we are using analog CMOS technology, CMOS device. And CMOS sensor, that camera sensor, are nowadays widely it is using to capture the high quality or high resolution picture. So for imaging purpose, CMOS is very useful. And another one of the greatest advantages, just now I told, the CMOS is easily scalable. CMOS means MOSFET is scalable device. Any type of MOSFET, either P-type MOSFET or N-type MOSFET, both can be scaled down. Means it can MOSFET can be reduced easily. MOSFET structure can be reduced easily, and the CMOS technology has supported the semiconductor industry ability to scale following Moore's law, which predict the doubling of the transistor density every 2 years. This has led to faster, more efficient, and more affordable electronic over time. So Gordon Moore is one of the eminent scientists, and he is the uh, co-founder of Intel Corporation. So the first he invented this Intel Corporation in 1970, and he first introduced the microprocessor, that is 4004. After that 8008 came, after 8080, then 8086. So different microprocessor came, but his Moore's law actually states that every 1.5 year, if we want to increase the device capacity in a single wafer, then what we have to do, we have to reduce the dimension of the MOSFET. So once the dimension is reduced, so we can increase the more number of capacity inside the wafer or inside the integrated circuit. However, as feature size decreases to the nanometer scale, currently, I think 3 nanometer and smaller than that. Samsung already fabricated one. Samsung and IBM already fabricated 3 nanometer technology devices. But still, there is a challenges. Means if we reduce the scale down, if we scale down the structure of the MOSFET, then there are several issues will come, like short channel effect, that I will not cover in this topic, because this is right now it is a very lengthy topic. So short channel is one of the important thing. It will continuously shrunk down the dimension of the MOSFET, and the what are the challenges? The main challenges is it will generate more leakage current, and heat dissipation is very high, and making further scaling difficult. Means below 3 nanometer technology, this Moore's law will not work. So as of now, most of the industries are working on 28 nanometer technology, but 28 nanometer CMOS technology, bulk CMOS technology. But below that level, that is 16 nanometer or 22 nanometer, or less than 16, there is 11 nanometer, 8 nanometer. That is very difficult to fabricate in the mass scale, mass production, due to different problem, like challenges are there, like due to the scaling of the devices at the lower dimension, there will be a short channel effect, then time dependent dielectric breakdown, hot electron effect will appear, then velocity saturation will appear, okay. Then wind induced barrier lowering, this kind of phenomenon will appear. To avoid such kind of issues, we our most of the industries are not following our means most of the industries are thinking about the dimensional scaling, because up to one extent this Moore's law will work. After that, it will not work. So for that, industry people are searching for novel materials like carbon nanotube, then graphene nanocarbon devices, graphene based devices, that is all are lower dimension, means one atomic thickness type of structure of the MOSFET. Means you can imagine the our hair diameter is micrometer, so it is 1000 times smaller than that structure, which is not visible in our regular eyes. We cannot see the MOS structure in our normal eye, because it is a 1000 times lesser than our hair diameter. So that level of research work is under process. So the few challenges I want to highlight, that is the main thing is that is leakage, that current leakage current. So once the leakage current is there, so definitely there will be a power leakage, because power is nothing but it is in proportional to I square R. It is proportional to I current square. So automatically power will consume more. So as transistor size will shrink, leakage current becomes significant and leading to high power consumption even when it is a ideal state. So when device is not working during that time instant also, a continuous power will flow from VDD to ground. So that is one of the biggest challenge CMOS technology. After that, the heat generation also one of the challenges. The increased density of the transistor generates more heat and creating thermal management challenges. And beyond CMOS technology, this is another challenges like research is ongoing into FinFET technology, GAA-FET technology, Gate All-Around FET technology, and emerging technologies like quantum computing and spintronics to overcome this limitation of CMOS scaling. So most of the industry people are now concentrating on this technology, FinFET, then get all around FET, then carbon nanotube FET, then graphene nanoribbon FET. So all are these type of materials are not bulk type. Industry people are thinking in that aspect because now Gordon Moore's law means Moore's law will not work. Finally, I want to say that CMOS technology remains foundation to all modern electronics, and due to its efficiency, then scalability and compatibility with digital circuits, because somehow we need to start from somewhere because it is like a CMOS is a benchmark device. From that device, we can initiate to construct some new things. So the CMOS fundamental is very important for all of us. So if we have very good fundamental idea about the CMOS, because what are the thing I discuss in this lecture, that is actually not sufficient because CMOS is not a very small. It is not a very small topic. It is a very vast area of research nowadays. So many researchers, then industry peoples are working day and night to invent some novel technology, but the background is CMOS. Means we cannot ignore the CMOS technology. Always we have to keep in our mind that this is like our grammar, vocabulary. CMOS is our English vocabulary. So we have to learn first the concept of CMOS. After that, we can try to implement some new things, new devices, new area of research we can explore. So we cannot think we can think beyond CMOS, but CMOS is our like a it's like our daily food, like rice. It's our daily need. So basic fundamental of CMOS is very much important for all of you. So thank you very much. I think I tried my level best to explain in details about the CMOS technology and the future prospect of and working principle of CMOS, then future prospect of CMOS technology. In my upcoming lecture, I will discuss in detail about the voltage transfer characteristics of CMOS inverter in detail, and how to design different types of logic gates, how to calculate power consumption of using CMOS power consumption of CMOS circuit, then how to measure delay of CMOS circuit, how to calculate the noise parameter in CMOS circuit, that I will explain in detail. So thank you.